Hello, seventh graders, and welcome to lesson 10.3, the extension part here in Unit 11. So in Unit 11, we only have 3 lessons. You have 10.2 extension, 10.3, and 10.4. We're not actually even doing the normal 10.3 lesson. So you're expected to get all this done this week and then take the test. There's no quiz for this unit. And so this extension is all about choosing appropriate measures. So as we've gone through and kind of explained, even in the previous unit, picking out what measure would be the best way to represent our data. And so here's going to be a little bit more direct explanation of what you should be choosing now that we know all our different measures and how we can choose them. So I've got one I can for this lesson, which is I can choose appropriate measures of center and variation to represent data sets. All right, don't worry about our warm-up. So choosing our appropriate measures. So there's 2 ways to choose our appropriate measures, and they all come down to looking at your data. So is your data symmetric? Or is your data skewed? Okay, so we were talking previously in this unit about histograms, as well as we've also talked about dot plots. Okay, so when we're talking about something that's symmetric, meaning maybe I have all my dot plots, maybe it's a dot plot, okay, and it seems to be, I don't know, we're just going to kind of make some dots. Oh, I think I accidentally erased it. Fun. Okay, so there's like, so I can tell that this is a very symmetric dot plot, okay? Seems to be the same measurements on each side. If I was to fold them, they're gonna match up for the most part. It can be a little different. It doesn't have to be exactly right, okay? If something is skewed though, especially on a dot plot here, is what you're gonna kind of see. So in this case, you can tell that most of the data is towards the left here and it's not towards the right. So that's what they mean when it is skewed, okay? So let's go ahead and read what these are. So it says the mean absolute deviation, or MAD, uses the mean in its calculation. So when a data distribution is symmetrical, use the mean to describe the center and use the MAD to describe the variation. Basically, the biggest thing to think about is if it's symmetrical, you use the mean and you use the MAD. I don't know what I did there. Sorry, I'm going to try and fix it. So you use the mean and you use the MAD. Okay. If something is skewed then, so it says the inner quartile range, or the IQR, uses quartiles in its calculation. So when a data distribution is skewed, what we then use is we use the median to describe the center, and we use the IQR to describe the variation. Okay, so the biggest thing again is just remembering, is it symmetric or is it skewed? And from there, then you're going to have 2 different measures. So symmetric's going to use mean and MAD, M and M, and skewed is going to use median and IQR. All right, let's go ahead and take a look at some examples here. All right, so we are given a dot plot. It says the dot plot shows the average number of hours students in a class slept each night. So you can see that we're going from about 6 hours to 10 hours. Each dot represents a student who voted for that many hours. Okay, so in this case on 9, it looks to be that 5 people slept 9 hours. What is the most appropriate measure to describe the center and the variation? So this is again describe the center and the variation. This is exactly what we just talked about here in the previous slide, okay? So we have to decide, is it symmetric or is it skewed? And in this case, 8 would probably be right by my middle, and if I was to kind of fold this up, it's not really going to match because most of my data, as you can see, is like right around here. I'd almost even kind of go out to here. So in this case, I would say that this is skewed. And what do you use for center and variation? We use IQR. and we use median. Those are going to be the best measures of center for this type of data. All right, so the next part here then, what they say is they want us to describe the center and the variation in the data. Basically what they mean by this describe is they want me to find those, okay? So we are actually going to find your median and your IQR. So I'm going to go ahead and write in these numbers in number order, and I will get back here in just a minute. All right, so I actually had to go through and write this all out. It took a lot of time, and I had to run into another line here, but we're going to go ahead and cross things off. Sometimes to make this go a little easier to find my median, I like to go like, oh, I'm going to cross 10 off on the left or 10 off on the right. I'm going to start with 5 though. So I'm going to go 1, 2, 3, 4, 5. So then I'm going to do the same on the other side. 1, 2, 4, 5. All right, not quite there. Maybe let's do another 3. 1, 2, 3. 1, 2, 3. All right, it looks like 1 and 1. And here is my median, this 8.5. Okay, so my median, 8.5. So now we got to find our IQR. Remember, once you do your IQR, you got to break it down into 2 different parts. So I'm going to try, it doesn't like me when I do this. Let's see if I can grab a different pen color. Well, let's go green this time. So I'm breaking it down. Here's your first part and the second part, and I have to find the median of each one of those. So I'm going to go through on this part here, and I know my line got kind of screwed, but let's go to 1, 2, okay, 1, 2, 1, 2. Looks like this is 7.5. I'll do 1, 2, 3. 1, 2, 3. 1 and 1. So 9. Remember, when you take your IQR, you're going to take then the median of the higher part, or that quartile 3 minus that quartile 1. So then my IQR is going to be 9 minus 7.5, which gives me 1.5. Okay, so here is then my IQR. So when they just ask you to describe them, that's really what they want to know. My median's 8.5, and then the variety of most of my answers is going to be within 1.5 of that range, meaning, okay, maybe 1.5 higher than 8.5, yep, or 1.5 less than 8.5. All right, let's keep going. All right, so here's a couple I want you to try on your own, okay? Let's just not worry about describing the center and variation right now. I just want you to decide, is it skewed or is it symmetric, and what measures would you use? Don't worry about actually figuring out those measures, okay? And then this one says, can you find the exact values of the mean and the mean absolute deviation, for example, 2. So this one, go ahead, yep, find the actual answers of those, and then we will come back. Alrighty, welcome back. So, number 1 is skewed on the prices of genes. So you're going to want to use median and IQR. And number 2, this weekly biking times is very symmetrical. And so I would say you use your mean and your MAD. Now, the reasoning part here, I'm not a big fan of this question because it says, can you find the exact values of mean and mean absolute deviation from the data in example 2? Explain why. Yes, I don't know why else you wouldn't be able to figure it out, okay? So it's not even asking you for the actual answers. It's just asking, can you figure it out? And yeah, I could take all this data and I could set it up and I can find my mean and then I can go ahead and find my MAD. Doesn't ask me to actually find it. So let's go to example 2. All right, so example 2 says the frequency table shows the number of states that border each state in the United States. So basically what it means is how many states does that state border. So if you think about Minnesota, we've got 3 other states that border us. Oh, sorry, 4. You've got North Dakota, South Dakota, you've got Iowa, and you've got Wisconsin. So in this case, if you're thinking about Minnesota, we would fall in this category of 4 to 5. And so it shows that there's about 22 states who also fall into that same category. So the first one is to display the data in a histogram. Okay, so I'm going to go ahead and start setting up my histogram. I suggest that you go ahead and pause this video. We'll set up a histogram and we'll come back together and then we'll talk about which would be the most appropriate measure to describe the center and the variation. Okay, so see you in just a minute. Alrighty, so here is my histogram. It's not going to look as pretty. My drawing skills are not up to par quite yet with this. But at the bottom you've got your frequencies, so 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9. These are your bordering states. Here is my frequency. I went up by an increment of 5, which was a little hard to make sure I'm showing the difference between like 3 or 2 or 13 or 10. That's just because I didn't have a lot of room here, but I would have maybe suggested going up by 2s again. And then I just labeled it as well. So if I'm going to go ahead and look at it, it says what are the most appropriate measures to describe the center and the variation. So let's go back and look at the note part. So we have to decide, is it symmetric or is it skewed? So if you remember when we were looking at this, I would say for the most part, this is symmetric. If I'm going to fold them, they're going to match up pretty well. Now they don't have to be 100% because 3 and 2 are different and 13 and 10 is different, but they're fairly close. So I would say that these are symmetric. When we are using symmetric, we need to use mean and mad. And that's it. It doesn't actually ask me to solve them. It just says, what are they? So it is mean and mad. Oof. It is lagging. Mean. I don't know why it is writing this awful. Mean and mad. All right. All right, so I want you to try this one on your own. So set up a frequency table. What appropriate measures would you use? What conclusions can you make from this? So come on back once you've got your answer. Go ahead and pause the video. Alrighty, coming on back, here is my histogram that I created with my labels and setting this up. What I can tell from my data then is that my graph is skewed, and so when it's skewed, I want to use median and IQR. So what conclusions can you make? You could say something about the best measures of center are median and IQR. You could talk about that the data is skewed. You could say anything that you can think about with this graph. You could say, okay, the most frequent mileage per gallon is 30 to 34. That would be the highest range. You could just say the smallest is this one. Anything that you can conclude from this graph would work perfectly for this part, okay? And that's it. So we only have one video for this lesson. Okay, don't worry about workbook, so on. And there's actually, I'm not giving you a worksheet for this. So there is actually no big ideas for this lesson because we already did so all the on your own stuff is basically what's going to be on there. So what I want you to do is take the time to do some IXL instead. I know I said that IXL is now going to be extra credit. So any topic you get done, turn it in and you will get extra points. So I would suggest you to practice this lesson, go ahead with that IXL, turn in whatever you finish and you'll get extra points. Also, code word, banana. Banana. Okay. All right, I will catch you in the next video. Have a great day. Bye.